This section is the bonus section. But first of all, I'll tell you the only required thing is you need to work part three, part four, and part five. The odd of part four and the odd of part five, but all of part three. And this deals with uh, valence electrons and the chart. You can do all of four and five if you wanted to. You should be able to do that. All of it. I just have you do the odd because it's something that's kind of a review. But I'm going to talk more about that in the next lessons. Okay. The other thing now, this is not required, but all the other sections you can just work the odd problems or more if you want to as a bonus. And I'm going to have you upload that as an extra assignment. Okay. So I don't think it'll take me too long to do this video. And this is something that you're going to need to know in college, even though it will not be on the AP exam. Everything I told you before is pretty important to know. But what I was telling you is, you can imagine that every electron in Hog Hotel, every Hog in Hog Hotel has its own little address. What floor are you on? Are you in the S, P, D, or F wing of the hotel? Okay. Thirdly, are you on the top bunk or the bottom bunk? Oh no, that's not the third. Oh, which room are you in? Oh, I'm sorry. So first of all, what floor do you go to? And then do I go to the S, P, D, or F wing? Now let's just say that I go to the third floor to the P section, where I told you, imagine Hog Hotel has S, P, D, and F wing, and that one's small, and that one's a little bit larger, and this one's larger, and that one is really a lot larger. Okay, so if you go to the third floor to the P wing, that tells you that which wing you go to. Thirdly, which room in the P wing? Are you going to PX, PY, or PZ? That's the third thing. And then the fourth, once you go in that room, are you on the top bunk or the bottom bunk? That's what the four quantum numbers do. So what I'm telling you is, you can write a letter to any Hog, any electron, and any atom. You can write a letter to them with this system, this quantum number system. And in the last video I talked about, okay, let's say for example, you wanted to get the electron in the 3s, but the one is down. I'll just say that's on the bottom bunk. Okay? Well, first of all, for that Hog electron on the bottom bunk, N tells you which level of the hotel you're on. Level 3. N equals 3. The L talks about, for L, you have to write this down kind of on the side somewhere, like on your paper, unless you want to just memorize it. For L, let's just, let me get another color. Orange will show up good. Yeah, I'll put it back on the top with the orange. Does that, yeah, that picks up. L equals 0, 1, 2, 3, 4, 5, and it keeps on going. But 0 is S, 1 is P, 2 is D. If L equals 3, it's F. Then G and H, those can also exist as you go on. Okay? So I don't know, can you really read that? What a bad... I tell you what, we know I'm doing Schrodinger, so I'll make it like this. L equals 0, 1, 2, 3, 4. Okay, S, P, D, F, G. And if you had to go to H, 5, and so forth, on and on and on. Okay, so since you're in the S wing of the hotel, the S orbital system, S wing, your L equals 0. Okay? All right, for ML, I mean, if you wanted to put N equals 3 or L equals, you could do that too. ML and MS, I talk about these two. ML is very easy. It's about one of the easiest quantum numbers. Okay, so watch this. S, P, D, and then F. Guess what ML tells you? ML tells you the room number. Haha. So, we'll go back up to this. I'll do another example in a minute. So ML tells you the room number, the magnetic quantum number. Now, I'll just start with the P system. Remember, there's 3 rooms here. 5 for the D and 7 for the F. Well, in the P system, the middle room number is 0. The one on the right, room number 1. And that room is room number -1. I know. If you had to go to a hotel and they say, oh, your room is number -2. You can kind of be like, what in the world? Is that I'm like crowned or below service quality or the super cheap one, whatever. For the D system, guess what? The middle room is always 0. So that's 1 and 2. -1, -2. And for this one, 0, 1, 2, 3. -1, -2, -3. Like you see here. And then for the S, it'll be just 0. So that's the only room number you can have for the S. So really, you can look at ML, you can look up here and just tell, oh, these electrons are in room equals 0, 1, 2. ML equals 3. For this one, ML will be 0, -1, I'm sorry, ML equals 2. ML is 0 for the middle. So ML1, ML2, ML0, ML -1, ML -2. For the p electrons, these electrons, the middle is ML equals 0. -1, ML equals -1 room number, and +1 room number for these 3pz electrons. Now, so that what that tells you is 2 electrons will have the same number for ML. All right. Same thing with these, but like for the 1s electrons, it has to be ML0. For the 2s electrons, ML0. 3s electrons, ML0. 4s, ML0. There's only one room in each of those. That's it. That's all you got to know. You can even write that. So you might write this on your paper, and you don't really have to write this. I think you can remember that pretty easy. Now, just because there are some questions on the paper about it, again, these are all bonus, the same way that from N, we can square N to tell you how many orbitals are in each floor, okay? And if you square it and multiply times 2, that tells you how many electrons are on each floor. Well, you can do something, oh, and also the little formula that tells you at any given level N, L will always equal every number from 0 up to N minus 1. The set of all values from 0 to N minus 1. I showed you that in the last video. Well, there's another equation. Your ML value. The ML will always equal the set of all numbers from -L all the way up to +L, including 0. Okay? So what this tells us is, let's just remember, let's do first I'll do a p orbital, then I'll do an s orbital, p, a d, and I'll do an s. I'll kind of auto order for a minute. All right, for the p orbital. For p orbital, L equals 1. For d orbital, L equals 2. For an s orbital, L equals 0. Okay. Now, so what are the possible values? You can use parentheses too. You don't have to use brackets, which I didn't do that great of a job. What are all the values for ML? All right. If L equals 1, ML can equal ML. So it's kind of like at L equals 1, ML can be any of these values at each of these different wings of the hotel. If L equals 1, ML is -L all the way to +L. That means -1, 0, or 1. If L equals 2, ML is -2 all the way to +2. -2, -1, 0, 1, or 2. And if if it's an s orbital, I gave you that big space. ML can only be, well, -0 is still 0, so it can only be 0. All right. So really, this just tells you, as I mentioned, if L equals 1, it's a p orbital. So you have, px, py, and pz. I don't know. I kind of wrote it. Usually I write it below it. Px, py, pz, px, yz, -1, 0, 1. If L equals 2, that means you're in the D system. So D, 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 D. Notice you have 5 values. So -2, -1, 0, 1, 2. So D, D. I won't even write the subscript names for those things right there. And that can only be the S. So again, this might seem crazy and all. Like, why do we need to know? Well, this came before electron configuration. So see, you can write down where every electron is in the atom just based on N, L, ML, MS. You don't want to really do that necessarily. Now, I'll tell you one more thing. Well, I might wait and I might bring it up again too and show you. Let me just show you this for a second. When you make these, I always do it this way. Well, let these be px, py, pz. When I'm filling this up, let's just say the first electron goes in. Can you see that okay? Yeah, I'll put one in px, then py, then pz. Then you double up, 2 in the px, then 2 in the py, then 2 in the pz. So I'll just take those out for a minute. Okay, well here's what I wanted to show you. When you write quantum numbers, it's called possible quantum numbers. When you're looking at an axis, x, y, and z, that's really your own choice, your own perspective to call that one x, that one y, and that one z. What if I were standing like on the other side of the board? Like what if you were holding that up, like I did earlier in the other video, hold up that little, whatever, axes, whatever, 3 axes, and you were standing on this side, your view might be, well, that's pz, and that's py, and that's px. Okay, why am I getting crazy about this? All right, don't worry about this. I'll just let you know this one deal. Calling this x, y, and z is just a matter of